To start today's lecture, we will take a look at the solutions of the problems in height and distance. Recall, the angle of elevation is looking upwards. The angle of depression, you are looking downwards. For this problem, what do we know? It says there is a man who is walking along the road, and when he is walking on the road, he sees a town somewhere up in the hills. From where he is standing, the angle of elevation is 30 degrees. When he then walks along the road for 80 meters, the angle of elevation changes to 60 degrees. Calculate the height of the town. To solve this, let's again give names to the different points. So the origin here is O, where he starts. Let's call the point after 80 meters A. The point here is Q, and this point we call P. The height is equal to the distance between P and Q. Since we know the distance OA, that's something we will want to use. So if we then look at other angles, we can say that the angle here on top, between the yellow and the red line, will be 60 degrees. For this angle, we know that the tangent of 60 degrees is the opposite, so it's the distance OQ divided by the adjacent side, which is the height h. Hence, the distance OQ is equal to h times 60 degrees, or h times the square root of 3. For the triangle with the blue and the yellow side, we know that this angle is 30 degrees. And so doing the same thing, we can say that the tangent of 30 degrees is the opposite. So it's AQ divided by the adjacent side, which is h. Or the distance AQ is h times the tangent of 30 degrees, which is h divided by the square root of 3. We then also know that the distance OA is equal to 80 meters. OA, as you can see from the picture, is just the distance between O and Q minus the distance between A and Q. And so OQ is h times the square root of 3 minus h divided by the square root of 3, or it's h times 3 minus 1 divided by square root of 3, which is 2h over square root of 3. And so then we know that h is 80 times the square root of 3 divided by 2 meters, or 40 times square root of 3 meters. In this problem there is a man lying on the road. From where he is lying, in the distance he can see a temple, and on top of the temple a flagstaff. From his point of view, the subtended angles are the same. Let's call that angle alpha. The other things we know is the height of the temple, which is 10 meters, and the height of the flagstaff, which is 20 meters. Call the distance between the man and the base of the temple D. From the green triangle, we then know that the tangent of alpha is 10 divided by D. And from the blue one, that the tangent of 2 alpha is 30 divided by D. We also know that the tangent of 2 alpha is 2 times the tangent of alpha divided by 1 minus the tangent squared of alpha. So this means that 30 divided by D is equal to 2 times the tangent of alpha, but that one was 10 divided by D, divided by 1 minus the tangent of alpha squared, so 10 divided by D squared, which gives, after some small calculations, 20D divided by D squared minus 100. So we have 30D squared minus 3000 is equal to 20D squared, or 10D squared is 3000, D squared is 300, or D is 10 times the root of 3. To find the subtended angle alpha, we can use any of the triangles, because we now know 2 sides. We know D, which is 10 times the square root of 3, and we know the height, which is for the smaller triangle 10 meters, or for the larger triangle 20 meters. So we will take the smaller one. In that case, we know that the tangent of alpha is 10 divided by 10 square root of 3, or tangent alpha is 1 divided by the square root of 3, so alpha will be pi divided by 6 radians. For the last one, you have a man standing on top of a cliff, watching out over the sea, and he sees one of the ships approaching him. When he looks down at the ship, his angle of depression is 30 degrees. If he checks again 3 minutes later, the angle has changed to 60 degrees. Denote the viewpoint of the man by O, the bottom of the cliff by R. This point we will be calling Q, and the initial point here is P. Denote the speed of the ship by V meter per minute. Then we know that the distance traveled from P to Q is 3 times V meters. By looking at the triangle ORQ, we can see that this angle is 30 degrees, and thus the distance QR is the tangent of 30 degrees times the height of the cliff, which is OR. So it is OR divided by the square root of 3. If we look at a large triangle ORP, we can make a similar remark. Then the distance PR is the tangent of 60 degrees. You can verify yourself that the angle is 60 degrees times the height OR. So this is OR times square root of 3. We then also know that the distance PQ is the distance PR minus the distance QR. So it is the square root of 3 times OR minus OR divided by the root of 3, which is OR times root 3 minus 1 over root 3. We also know that PQ is equal to 3 times V, and thus 3V is equal to 2 over root 3 times OR. Or OR, the height that we are looking for, is 3 root 3 over 2 times the speed. However, we do not need to know the height. We need to know the time it takes for the ship to arrive to shore. So we need to know how long will it take to travel from Q to R. To do this, we look back at QR. So we saw that QR is OR divided by square root of 3. So OR is 3 times the square root of 3 divided by 2 divided by root 3 times V, or we have 3 over 2 times V. And thus the time from Q to the shore will be T equal to QR, the distance QR, divided by the speed V. So it is 3 over 2, 1.5 minutes.